Hey, before we get into today's video, make sure and check out Tacoma Wind Supply. They're a preferred supplier. From anything from bulk materials such as pavers and pipe, to water features and low voltage landscape lighting, and drainage and pumps, Wind Supply is a one-stop shop as a pro for the supplies and tools you need to get the job done. Alright, so what we're up to today is we're installing a Rainbird ICWM water meter on our well line for our house. And what we have here, this is the actual meter itself. It comes with a length of wire and an antenna, and it's a little bit muddy. We've been lining it up for the installation and how much to cut out. So this is a 3/4 inch. They make them up through 6 inch, and when you get past anything below 1 inch is not a flange connection. So the meter itself is plastic. The actual housing swivels on top. It is a digital meter rather than analog there. And so the great thing about these meters is that they actually are cellular enabled. So they actually upload the water usage to Rainbird's cloud, and you can log in and see what the activity's been. It's almost to the point where if you have somebody at home, a family member or a spouse taking a shower, you can actually see when that event is. It breaks out kind of a bar graph. So what you get when you buy a Rainbird ICWM is anything that's non-flange. You get 2 meter tail pieces. So the interesting thing about a lot of meters is these are AWWA certified, which is an industry certification for water meters, is that the meter tail pieces are a straight cut thread. So this is iron pipe thread, and it is actually a taper thread, whereas the meter thread is a straight thread. So you can't just use a threaded pipe coupling, say 3/4 inch to hook onto this, or 1 inch to hook onto this. It won't work. So what Rainbird does, they supply the meter tail pieces, and then they use a rubber washer on the inside, and that threads on there. And it also allows the meter to be removable if it needs to be serviced, or maybe it's an installation where you want to remove it on an irrigation system for the winter. So you can see the washer just sits on the end of the thread. We line up our tail piece, and you can see it's got a flat mating surface. You want that to be clean. We hold it on there. We bring the nut down, and these only really need, in my experience, these only really need to be hand tight if they're clean threads. And then if you want to, you can use a wrench. They don't have to be we don't have to put a pipe wrench on them. So that's the setup for the meter. Now, when we look at our hole here, right off our wellhead, you can see there's a cable in the ground. That's the power to the well. And then underneath our house, we have a pressure switch, a bladder tank, and that's the actual control for the well. So power's off to the well, so the well doesn't prematurely start pumping water out. And this is a 3/4 inch poly line. The well dates back over 50 years old, and we had a hose bib down here, but it's bent, it's missing the handle, it's not really easy to use. It's also a restriction trying to pull water off. We need a lot of friction loss. So what we're going to do is, after our meter, we're going to put in a T with a full port ball valve, so that we can tap off, we can put in a backflow printer, and then we can run irrigation off of this. And so in our installation, we're going to be using a couple of barb fittings. I've still got plastic on these. So the barb fitting, we're going to use a coupler on one end of the meter, so we can couple onto that meter tail piece. And then this side's barb, that's going to go inside our poly water line. Now, depending on what type of poly you have, you may end up needing to use a pack joint with a stiffener. It's more of a compression style not coupling, but adapter. Well, in this case, we're going to be using a barbed insert. Alright, so if you look down the hole, we've got where we made our initial cut outside the well head, and we were able to get the T out of there. Now, one important thing to consider is that a lot of jurisdictions require double clamps on poly. You can see here we have one clamp, and in the case of doing this double clamp, we'll bring it back at the end. We'll have another clamp opposed to the other side. Now, this was a PVC T, and you can see all this orange, actually corrosion from the galvanized pipe. So we pulled it apart, and you can see this was the hose bib that we were removing. You can see it's bent. We can see a couple different couplers in it. You can see the amount of scale, and that rust actually eats away at the thickness of the pipe. Now, this could be black iron, it could be galvanized, I'm not quite exactly sure. And if we look down the inside of it, you can actually see there's not too much corrosion. A lot of times over time, galvanized pipe, depending on the water, depending on the soil type around it, can actually rust solid. You can actually see restrictions, say in a house, where you'll get reduced water flow. So it was a good thing we were pulling this out. Just one less thing to have go wrong. And we generally don't install galvanized. A lot of times, if we're tying a water line, we may advise to have the water in place if it's galvanized. As soon as we touch it, there can be problems that start happening just from vibration to tools. Sometimes you go to grab the stuff with a wrench, you'll break through the side of it and cause a little hairline leak, and it just becomes a lot more problems, and they can show up over time too. And then if you take a look at the inside, you can see our poly. I'd say it's a thin wall. I don't know, we don't use a whole lot of poly up here for irrigation, but the other stuff we'd see is an HDPE. It has a similar wall thickness to a Schedule 40, like a PVC or galvanized. That's where we'd use a pack joint fitting with a stiffener. In this case, we're going to go barbed. So we're going to start putting this together. Okay, so it's been about an hour later. It's January, so it's starting to turn into dust. Sun's starting to set behind us. So we got the install done. We got 2 valve boxes. You know, if you go to the home centers, you'll get a lot of them that have the black sides, and they're really not that strong. These ones come from one of our suppliers. They're all green. They're a lot stronger on the sides. What do you call it? A standard box. A company called NDS. I think makes these. Are kind of a clone. So we got 2 of those we're going to set over it, and then now if we look down the hole, you can see we have working from the wellhead up out towards the house. We have the water meter, we have our T, we have our tap coming off for future irrigation, or basically just for a nice hose bib, full port, no restrictions. And then the thing I want to mention that I took a picture of is that this is how you double clamp or opposed clamp is required by a lot of water purveyors. When we tap into a water line, you can see that it's all brass. We have our tail pieces as supplied by Rainbird. We have our reducer bushings. We have our T. Now, in between our shutoff valve and our T, this is a Schedule 80 machine nipple. And this ball valve is yellow brass, whereas the T and the other fitting are a red brass. With the poly nipple, the Schedule 80 machine nipple there is just It's just kind of a just so we don't split any of the fittings. Sometimes, in my experience with yellow brass, it's a lot thinner, and it can have a tendency to split if there's too much, if it's too tight, if there's too much tape or dope on it. And all the blue is a Blue Monster pipe tape. It works really well for doing brass. We don't use any Teflon. The other stuff we use sometimes is from a company called Leak Stop. It's FDA, it's drinking water safe. So the tap or T for now is not going to be used. It's kind of something we put in for future use. We tap it in real close to the well just so we don't have to deal with a lot of friction loss, because irrigation's high volume and we need the pressure as well. And high volume, you can also experience a lot of friction loss. The last thing, this is our antenna. I don't know how the reception is going to be. We're out in the open. We live on an acre. We're surrounded. There's no other structures around it. So we'll probably end up mounting this inside the valve box, probably near the lid. Sometimes if you have a deep meter installation, Rainbird earlier on had some issues with the connectivity. And I also believe these have a 5-year data plan. So we're going to go ahead and get the well turned back on, get our hot water heater turned back on, and then we'll do a quick video at the computer once we get this thing about 24 hours to get some readings and some usage, and then have time to upload. Okay, so it's been about a month since we installed our Rainbird ICWM, our basically web-enabled or cellular-enabled water meter on our well line, our main line to our house. So what I want to do today is take a little bit of time and go through the web end of it, how you access the data. So to do that, we're in our favorite browser, which in this case is Vivaldi. We go to icwm.rainbird.com. I've already registered the meter. As you can see, you can create a new account. Typically forgot password. So remember my username, so I'm going to go ahead and put in my password. Looks like it took that, so now it's loading. Okay, now first thing, when it gets to the home screen, you can have it go, default to different screens. Right now I have on our account lookup. That's what I've been using it under. And I had a little bit of trouble at first finding the actual meter. So if you look right here, you can go select and you have an all installed meters, all installed meter dash new installs, or all accounts. And I believe it's just a category, but my meter only shows up under all accounts. So you can see we have our ID number, a size reference, billing read, and then 24-hour reading. So I'm going to go to the 24-hour reading. Now these meters only upload at midnight. So it's not a live feed of what's going on. So every 24 hours, so say, on the 20th of February 2019, it did all the reading, and at the end of the day, at midnight, then it uploaded that. And that's the data we're looking at today, is actually from the previous 24 hours. So looking at a couple of quick graphs, you can see on this one, we can actually see in gallons per minute on the side, we actually can see the different events, and we can actually see the flow rate. And in this case, we're on a well, so we don't have a nice gradual bell curve that you'd see on a say a typical installation where the use can slowly ramp up, peak, and ramp back down. In our case, we have a pressure switch in a bladder tank, so as soon as the pressure drops, the pressure switch cuts the pump powers up, we hit our peak flow rate, and then lasts as long as we're using water, as long as the pressure stays below the cutout point, and then once it cuts out, the pump turns off, our flow rate drops back down to 0. And these increments last, it looks like they last about 5-minute or 5-minute intervals. So 12:45, 12:50, gradually 12:55. So, and you can see basically get up to about 10 a.m. had no flow. All of a sudden, 10:05, 2.63 gallons per minute. And you can see it tapers off down to 0.37 at 10:10, and then at 10:20 its flow rate is 0. And then same thing later on the day, 6:35, looks like 6:35 or 6:40 p.m. We peak all the way up to 2.96 gallons per minute, and then at 6:50 we drop back down to 0. And then if you look at the gallonage, you can actually see the usage. So Right in the timeline, kind of near the spikes are at, you can see 14.8 gallons per minute, or excuse me, 14.8 gallons, 15 gallons, and then 14.8. And you can kind of see, if we look at our timestamp at the bottom, our timeline, that'd be about 12 a.m. military time, and we'd be somewhere about, I'm guessing 10. See if we can, yeah, about 10 a.m. And then right here we're, it doesn't do anything when I click on it, but right here we get into about, I'm guessing it's probably about 1800, which would be about 6 o'clock. And you can see for the day, total consumption of 44.62 gallons. And that's what's flowing through the meter. So depending on where you have this meter installed, if you had a T of some sort before the meter, it wouldn't record the flow before the meter. It's only going to record the water that passes through the meter. So it's really important that you understand the layout of the piping and make sure you have it positioned correctly to capture the water flowing through. So next thing I'm going to go down is I'm going to go down to analytics on the left hand side. Give it a minute to load. So once again, we want to make sure that we're on all accounts. Right now we don't see any data, so I'm going to put it into all accounts. And now we can see our meter. Now the first one we can see is this graph showing current consumption by flow rate. So you can see that we spend most of our time up here in this 1 to 5 gallon per minute range. And it looks like it says 97% of the time based on, it looks like it to be our last week. Now if I go to 1 month, we can go different dates. You can see this time we're 95% of the time we're in that 1 to 5 gallon per minute range. And then you can see we spend like 0.49% of the time in the 0 to 0.25 gallon per minute range. And you can see it also breaks it out down here. Now our well line's 1-inch thin wall poly. Don't know much about the pump or anything else. Right now it works. So we're kind of in a low flow range. Most houses I'd expect to see anywhere up between the 5 to 10 gallon per minute. Maybe all in the, I wouldn't say 50. We might be in the 16 to 20 gallon per minute range. Especially with irrigation. As we move into more of a commercial end, you might end up here into the 250 to 500 gallon per minute range, especially if you have a large site with like a 3-inch meter or a 2.5-inch meter. Especially when you have a leak condition, will hit the, you can hit the that 300 plus gallon per minute range. So next one I want to do is up here on the top, where right now we're in flow rate analytics. We're going to consumption analytics, and you can see based on the days, you can see when we've used more water. So you can see on the, looks like on the 4th. Moving into the 5th, these days had higher consumption. So we could have been doing laundry, maybe there's an irrigation event, that sort of thing. Now we'll also look at comparative analytics, time-based. So you can also see based on that 1 month range, we can see between, we can see when we're more likely to use water or when we're using water more. So you can see, 9 a.m. to 10 a.m., 1 p.m. to 2 p.m., 9 p.m. to 10 p.m. And you also look at leak analytics, and there's something you can set up so you can actually look at, say on a normal house water line, maybe there's no water usage, but maybe there's begins to become a 0.25 or a 0.5 gallon per minute, just kind of baseline that starts happening. So the next thing I want to go down to is system status. You can see we go again back to all accounts. Now the notices here, I don't exactly sure. I've gone through all the settings. I haven't exactly figured out exactly what is going on. But this interface is made for utilities, contractors, homeowners. So there's a lot of different individual settings you can get into. And in this case, what we're looking at is, we're looking at missing readings and the actual reading. So say we had if I go into 1 month, say we had a reading that didn't go through, or it's late, but it looks like everything here we're green. So next I'm going to go down to settings. Now this is where you can get into some of the alerts. So if I go into condition priorities, you can see that we can set different priorities. So say we have say we want to know we have a communication error, we can actually drag that all the way up so that if we have a communication error that does that takes the highest priority, or maybe we have a an unexpected use. Maybe this is a park and somebody's illegally using a hose bib on a bathroom structure. So we can look at that sort of thing. Also, we can also set it up so that once we have our condition priorities, we can set up, for leaks. So that if we have a leak, we can notify a group of people that there's a problem. Maybe it's high usage, maybe a backflow condition. That'd be something, say you have a lower pressure before the meter and the water actually will flow backwards to equalize on both sides of the meter. Maybe zero usage, so let's say during a day, all of a sudden there's a zero usage. Maybe we're expecting a specific zone of irrigation or a specific water event to happen, and it didn't. High meter flow, so maybe we had a complete break in a line. And so those are all things that we can set up, and you can see on a 5/8, and it gives you some baselines here where it says what to expect. 5/8 inch meter, 15 gallons per minute. And if you get all into larger models, it's 1,500 gallons per minute. So that's just what I wanted to kind of go over really quick, or just some of the basic features of this. And we'll go back to kind of our overview. We'll look at all our counts. And you can see, back to the basic bar graph. So really, it brings together a lot of data. And the nice thing is, like I said, is that we can actually see how much water is flowing during the events. We can get ideas of, when we're using the most water, at what time, what times. So if you'd like to learn more about us, you can always get a hold of us through my email, corey.johnson@jipnorthwest.com. Feel free to shoot us an email. You can always call us at 253-268-5385. Well, I hope everyone found this useful. If you have any other questions, please feel free to reach out to me, or you can always get a hold of Rainbird. If you'd like to order one, you can always get a hold of Wind Supply in Tacoma. Alright?